Good morning, everyone. I hope everyone had a nice weekend. Welcome to today's webinar titled Testing Considerations for Beyond 10G, brought to you by JDSU. My name is Robert Soprano. I'm a Channel and Sales Associate at JDSU, and I'm going to be your host today. Today we have presenting Branislav Barta. He's a fiber specialist at JDSU, and he's going to take us through this technology in this webinar today. The webinar is approximately 1 hour in length, with a 45-minute presentation and a 15-minute question and answer session. So if you have questions, please feel free to submit them through the question and answer panel or the chat panel on the right-hand side of your screen. You should not need to dial in using your phone. You should be able to have audio streamed directly through your PC. But there is an info tab in the upper left-hand corner of your screen which provides global call-in information should you prefer to listen via phone. So without further delay, I'd like to hand over to Branislav and welcome you to this webinar.
Okay, good morning to everyone. As Robert already introduced me, my name is Barta, and I will do today's webinar. Aim of today's webinar is to share some information and knowledge regarding testing, cabling in data centers, means connections inside the data centers. And the name is Testing Considerations for Beyond 10G. Okay. Yeah, today's agenda. Needs for speed and growth of IP traffic, fiber versus copper, then fiber considerations, tightening requirements, testing considerations and practices, copper considerations, current cabling standards update, and testing requirements. At the end, conclusion, proactive testing certification. Let's start with introduction. This is quite nice, I would say, graph which was made by Cisco about 1.5 years ago, which is telling us how the needs or demand for data transmission are exponentially growing. If you look to this graph, there are some milestones. In 2003, what happened? It means consumer internet surpassed business internet. It means the private data transmission reached the level of business data transmission. In 2 years ago, or 3 years ago, in 2010, also internet video surpassed peer-to-peer as the largest consumer internet video traffic category. Also, last year, internet video reached 50% consumer internet traffic. Means it's amazing that the internet traffic, 50% is occupied already with video. Also, last year, the number of households generating over 1 terabyte per month hits the 1 million mark. This is also a significant I would say, increase of data. What are the plans? In 2004, next year, 1/5 of consumer internet video now originates from non-PC devices. How to translate this message? Up to now, we were more or less speaking about data transmission generated and received by PCs. And nowadays, there is a significant movement due to 3G and nowadays 4G mobile telephony, that the video is now received by mobile phones owners are watching video on the mobile phones. And it is, I would say, this portion will significantly grow. In 2015, what are the, I would say, expectations? Internet traffic from wireless devices exceeds internet traffic from wired devices. It means in 2015, within 1.5 years roughly, the traffic from mobiles, gently saying, will even be larger than data communication through the PCs connected to the fixed lines. On the other side, it is visible from other trends. If you look to the telco operators, those who are able, they are merging with GSM operators, and telco operators, incumbent telco operators, they are less and less investing to the fixed lines and more investing to the 4G technology, which is also called LTE, the related technologies, fiber to the antennas. It means there is a significant movement from the fixed line data communication to the wireless line data communication. And also in 2000, we are starting to speak about zettabyte thresholds. If I'm right, this is a volume 10 to 23 bytes. Enterprise network, how looks now and in the near future. Today's topic is more or less related to this part of the enterprise network, which is connecting access switches and customer premises, and also access switches connecting to the core switches routers. Means we are speaking first about 100 meg connection, 1 gig connection, 10G connection, up to the PCs or devices at customer premises. And also we are going to speak about data transmission between switches and routers, mainly in data centers. Of course, it is related to the storage area network, 8 fiber channels, 1, 2, 4, 8, even nowadays 16 meg bit rates. And the question is, which links will be used? Electrical or optical or both? And the answer will be done within today's webinar. Okay, again, certain kind of retrospective look how the Internet electrical and optical was growing. At the beginning of the 90s, 10 meg Ethernet over electrical interfaces, copper cables had been done. If you remember, at that time, even 16 meg Ethernet exists. It was a token ring technology. Later on, in the middle of 90s, 100 meg electrical interface was available, and at the end of the 90s, beginning of a new century, 1G electrical Ethernet was available. Nowadays, when we are speaking of about electrical interfaces if you are buying new notebook. 1 giga Ethernet interface is already standard on the notebook, and sooner or later 10G interface will come. Regarding fiber, the development was a little bit delayed. 10 meg optical interface is not common, means this 10 meg interface was not significantly deployed. 100 meg, this was, I would say, a real start of fiber deployment, and nowadays 1G optical interface is a standard, as well as 10G optical interface. What is brand new, that 40G as well as 100G optical interfaces becomes as a standard, because last year there was a huge deployment of 100G and a little bit less 40G systems. Means these optical interfaces are already available and already deployed. Copper versus fiber. What are advantages? What are disadvantages? Copper is the technology is known and understood. If I'm speaking about technology, I mean Ethernet over copper, 10 meg, 100 meg, 1 gig electrical interface. What is advantage? Easy to install, easy to terminate. It's easy for MAC address communication. Packet over Ethernet is done. And another advantage is it is each time backwards compatible. It means you have interface. Let's look to your notebook, which is able to communicate over the same electrical interface, which is able to handle 10 meg, 100 meg, as well as nowadays 1 gig electrical interface. Disadvantage of the copper is that nowadays the copper optical interfaces, as well as the concept, reached certain kind of limits. We are going to speak about that later on. In the case of fiber nowadays also becomes a standard, but up to now not too much understood by IT guys. This is a permanent problem because they are considering still interface as interface. They are not differentiating too much between electrical and optical interface. For them, it is interface as interface. It is a little bit harder to install optical interfaces, optical cabling, as well as to terminate. Advantage is that there is very high port density if you use small form factor of LC or MU connectors. Fiber is much more secure than copper medium. And I would say significant advantage of the fiber is that with the fiber you are able to reach much more longer distances as with copper. We are going to discuss it soon. There is a question mark regarding the power and heating because electrical interfaces in the past there was a significant requirement for output power. Nowadays, the request for output power of signals is significantly dropped down. Means no more, I would say, such strict requirements for heating. Question mark is regarding port density in the case of the copper interfaces. I mean classical RJ45 interfaces. In the case of fiber, optical interfaces depends on the output power, has generally a higher power consumption. Regarding pole density, I already mentioned it. It is much more efficient because you can put on a patch panel much more optical connectors, for example, LC connectors, than RJ45 electrical interfaces. Fiber considerations. Here you can see from this table differences between 4 different type of cables, OM1 up to OM4. Here there are displayed wavelengths used, and here you can see some limits for 1G Ethernet. What is the maximum allowed insertion loss for connection at 850 nanometers at 1300 nanometers? Of course, it is related to the maximum reachable length. And here you can see these limits. This table is telling us what are limits for 10G in comparison with 1G. Look, for 10G the limits are much more tougher. Means it is allowed lower attenuation than for 1G. Of course, if you compare, in the case of this OM3 type of cable, the reach for 10G is much more shorter. Here we are speaking, in the case of 1G, about 1 kilometer, in the case of 10G, about 300 meters. And look to the comparison between 10G and 4100G. At present, only 850 nanometers wavelength is defined, means allowed budget for insertion loss is 1.9 in comparison to the 6 in the case of 10G. It means, again, much more tougher limit. In the case of OM4 cable, the limit is even lower, 1.5 dB per connection. Here you can see what is possible reach with this type of cable and for this bitrate. It means we drop down from 300 meters to 100 meters in a case of 4100G, and here from 550 meters to 150 meters only. Okay, some vendors allows greater distances. Depends really on the vendor. It is related to the sensitivity on a receiving side. Okay, another parameter. Please don't mix them, because here on the previous page we were speaking about total allowed insertion loss per connection, which is directly related logically to the maximum reach with the cable. Here on this new table we are speaking about attenuation, means insertion loss per kilometer. It is the same because it is not possible change. It's done during manufacturing process of the multi-mode cable at 850, and the same in the case of second optical window 1300. The attenuation is a fixed 1.5 dB per kilometer. Here we are going to speak about single mode cables. Single mode cables, they have much more lower attenuation, means insertion loss per kilometer in comparison with the multi-mode, means much more lower. We are speaking about 1 dB per kilometer, even less. Here this is a typing error. Yeah, it must be. It should be 0.2, 0.3 maximum. Yeah. Okay. What is very important to keep in mind that up to now we were speaking about full fiber. It is necessary to take in consideration that each fiber has to be terminated with an optical connector. Also, in some cases, fibers have to be spliced together. Means you should take in consideration that there is a limit 3/4 of dB per connector. This is a maximum limit. The ideal or good optical connectors should have insertion loss about 0.5, even less. I would say the good connectors nowadays, they have insertion loss 0.25, 0.3, and in the case of splices, good splices are somewhere around 0.1 dB per splice. Keep in mind, I'm speaking here about multi-mode, not about single mode fibers. Okay. Multi-fiber push-on, pull-off connector introduction. Abbreviation for this type of connector is MPO. Alternatively, MTP. Means these multi-fiber push-on, push-off cables, they are putting together several fibers. It can be 8, 12, 24, 48, and so on, in one linear array. Means there is a flat fiber cable which consists of 8 and more fibers inside. And this bunch of fibers is terminated with one type of optical connector. We are speaking about a multi-fiber connector. Means these connectors, time to time, are called also ribbon. Means you have several optical fibers manufactured together in one flat cable. What is the purpose of this special MTP, respectively MPO cables, which are also using connectors? There are manufactured special breakout cassettes. Breakout cassettes, the aim of this cassette is to have access to the data connection between switches, routers. And you will see on the next slide how it is deployed. On one side, there are typically LC connectors, and opposite side of the breakout cassette is MTP connectors. It can be 12 fibers or 24 fibers for 40G and 100G lines. This is an example how looks such a special cable, multi-fiber cable equipped with MTP connectors. Okay, here you can see how usually it is connected. We have a router in data center which should be connected with a switch in telco room, and between this telco room and data center there are two optical patch panels. And between optical patch panels, to reduce number of individual touch cords or pair of touch cords, are used these special multi-fibers which can be terminated with NPO or with this MTP connectors. Okay. What becomes a problem here if we are speaking about the optical interfaces? Contamination of optical interfaces. For that purposes, it is necessary, mandatory, to perform each time inspection and cleaning of optical interfaces. The inspection is done using special optical microscopes, and these optical microscopes nowadays should be able to perform pass-fail analysis, because there is a standard which is called TIA 568 Annex E. Also, this is called as IEC 61300-3-35, and this standard specifies how clean the connector should be. Means there are defined some zones. A zone, core. We are speaking again in this case about multi-node, and B zone, cladding. And there is a defined in this standard how many scratches are acceptable. For B zone, there is no limit. And for scratches which are I would say thinner than 5 microns, there is no limit. For scratches which are wider than 5 microns, 0. Defects, maximum 4 defects, means the defect contamination are smaller than 5 microns, and there is non-acceptable contamination which is larger than 5 microns, and about similar limits for cladding. What is very important for you if you are using such cables, that to have a standard microscope is not enough. You should be equipped with optical microscope which is able to perform pass-fail analysis according standard, according this standard. Otherwise, you are lost, because we are human beings, and for somebody, the look on the optical, the surface of the optical interface looks, oh, it's clean. For another person, oh, it is not clean. And this standard strictly eliminates impact of personal, I would say, interpretation if it is clean or not. And this standard even has some chapters or some paragraphs, and the standard is defining conditions for multi-nodes as well as for single nodes. And these conditions are different. Oops. Okay, here you can see output from the inspection. It means optical microscope is able to communicate with PC or with inspection device, and is able to generate final reports. What is really important, there is under preparation a new update which is called Annex E, and where is explicitly defined how the inspection should be performed, what are the conditions, how I would say optical microscope should work, what should be able to detect, and so on. Here you can see example from a single mode MTP connector, APC polished. Look, now we are going to speak about single modes. Previous pages were related to multi-mode. You can see the difference, not only in the view, differences regarding the thresholds. And now I'm going to speak about inspection of single mode optical fibers. And you can see the different thresholds for core. Core is in this case here, and cladding is this one. Means there is no allowed scratch which is smaller or narrower than 4 microns. Non-defect. It is allowed only for cladding defect. There is no limit for scratches. Defects are allowed. There can be 5 defects with a size of from 2 to 5 microns. But none of them is allowed if it is larger than 5 microns. For example, like this one. In that case, the parcel analysis according to this already mentioned standard will not pass, will fail. This is what I wanted to mention before, that we have connection between the switch and telco room. And from these switches, there are interfaces, LC connectors. The same in a telco room on another technology. And the idea of this multi-fiber cables deployment is to reduce number of fibers, not fibers itself, I would say touch cords or cables between switches and telco devices. Means there is this special drop box which is converting standard LC patch cords to the MPO cables, and MPO cables are going to the fiber distribution frame. Within fiber distribution frame, there is again connection using standard LC patch cords, and from the opposite side of the distribution frame, there is again the flat multi-fiber cable, which is reducing the number of individual fibers. And from this slide, you can see how important inspection and cleaning is, because if this MPO connector is contaminated, is able to impact all individual fiber data transmission. Also, inspection and cleaning these MPO connectors is very important, because can you imagine we have, for example, 8 fibers inside this MPO cable, and if one optical interface is contaminated, it is impacting the traffic. But how to detect, how to clean this individual optical interface from 8 optical interfaces which are integrated in one MPO connector? You have to disconnect it. It means because of one contaminated optical interface, you have to disconnect other 7 fiber connections. It means this becomes a really crucial and very sensitive issue, contamination of the optical interfaces. Due to that, it is necessary to inspect and to clean proactively these special MPO connectors. What should be certified? There are devices available on the market which are testing these special patch cords, multifibers, or individual, doesn't matter, between optical distribution frames and technology devices, and you are testing using again pass-fail analysis, but in this case regarding insertion loss and regarding the attenuation, and these devices are able to measure insertion loss of the connection between distribution frames as well as between technology devices, means switches, routers. In this case, it's crucial, don't forget to perform so-called reference measurements. Reference measurement means that when you are performing measurement between distribution frames or between switch and router, you have access to the optical line with your device. You have light source and power meter in one device usually, and you have to use some optical measurement patch cord. Each patch cord is adding insertion loss, is adding insertion loss due to own optical connectors. To eliminate, and you have such measuring patch cords on both sides. You have to eliminate this added insertion loss performing reference measurement. Means the reference measurement is saved to the power meter and then is taken in consideration during calculation of insertion loss of other measurements. Simply saying, first, you have to perform a reference measurement to save a reference value, and then you have to keep the same optical patch cord which you use for reference measurement, including these test jumpers, and you are just connecting the fibers to your measuring patch cord on both sides to eliminate additional insertion loss. It is very important. In the case of multi-mode cables, it is even a little bit more complicated, because as a measuring patch cord, you should use special launch, I would say small launch fiber with this black box, and this black box is managing so-called encircled flux. This is a new standard which requires that when you are using multi-mode source, you should have enough coherent light which fits to the diameter of multi-mode cable. The purpose of this box, this EF module controller, is that I would say concentrating light to the dedicated diameter. It means each time, in the case of multi-mode, you should use laser source, of course, and instead of a standard patch cord, this special EF module controller, and then you will generate, I would say, the proper light. It means this is consider this combination as a measuring device with integrated measuring patch cord. This is, I would say, new in the case of multi-mode measurements. Okay. How the fiber should be certificated? You should use not only a laser source and power meter to measure insertion loss. You should perform also OTDR measurements. Why? OTDR measurements are also performing the reflectances detections as well as calculation of optical return loss. Here you can see from the optical trace, which was obtained on a OTDR, you can see some reflectances, these spikes, as well as attenuations. And each connector is generating certain kind of reflectance and as well as certain kind of insertion loss. If you remember, we were already speaking about certain kind of limits, that there is a limit, the insertion loss of the connector shouldn't be higher than 3/4 of dB. Insertion loss of splice shouldn't be higher than 0.3 dB. For this purpose, you should perform OTDR measurement, and OTDR will tell you immediately if everything is in visual limit or not. Also, there is another, I would say, requirement that you should use specific so-called launch cable as well as tail cable. This is, I would say, for long discussion, but simply saying OTDRs are not able to measure insertion loss of the first connector as well as last connector. For this purpose, it is necessary to put between OTDR and measured fiber connection launch cable. At the end of the measured fiber, it is necessary to connect so-called tail cable or tail jumper to be able to measure insertion loss of last connector. Okay, this is example. There are some traps and pitfalls in the case of OTDR measurement. It is necessary to take in consideration that there are some limitations of OTDR. I am not speaking about JDSU OTDR. OTDRs, generally any OTDR has a limitation, and the limitation is called even dead zone. It means you are not able to detect two optical connectors which are too close to each other, and too close means that the distance between two optical connectors is shorter than defined or declared even dead zone of the OTDR. You are not able to see the second optical connector because it's hidden by reflectance from first optical connector. This is example. For example, here you can see two spikes, and I am able to read out from these two spikes that there are two optical connectors close to each other. Also, from the trace, you are able to read out and you are able to detect with OTDR immediately some problematic optical connector which is creating very high attenuation. Means if you wouldn't have OTDR, you can spend a lot of time with inspection, cleaning randomly, I would say, bunch of optical connectors. With OTDR, you are able to properly detect immediately which connector is contaminated, and you can go directly to the location where connector is located, and you are able to then inspect and clean. Here from the trace you see significant insertion loss, which represent in this case about 8.5 or even more dB per connector. Remember, we discussed that the limit for a connector insertion loss is 0.75 dB. Here we are speaking even about 8.6 dB insertion loss of the connector. Okay, couple considerations. What is, I would say, certain kind of development, the beginning, category 5, later on 5.8 for 100 meg connection was available on the market. We are speaking about mid of 90s. Later on, category 6 came at the end of 90s. Here on this axis, you can see the frequency range which is used for transmission. Means in the case of category 5E, we are going up to 100 megahertz. In the case of category 6, we are going up to about 300 megahertz. Later on, the category 7 came. Category 7 is using copper cables up to frequency range 600 megahertz. And nowadays, we are speaking about category 7A. And category 7A is going above 1 gigahertz. And there is a question mark, what will be used in the case of 40G. As I know, this year is expected certain kind of standardization, and if I am right, we are speaking about so-called category 8. There are some rumors that maybe it will not be category 8, will use a different, I would say, labeling. But let's speak about category 8, which is going beyond 1 gigahertz frequency range. What are the problems with electrical interfaces? If you remember at the beginning, we discussed it a little bit. There was in the past huge request for output level. It means they should generate, I would say, the power 10 watts. Nowadays, these requirements drop down significantly due to huge improvement of the quality of the electrical cables, copper cables. And nowadays, we are speaking about 4 watts. Even that there are expectations that this 4 watt output power will drop down to the 5 watts. Okay. What is behind that? Significant improvement of the quality of the cable. I don't need too much strong signal to keep certain, I would say, signal noise ratio. If I have enough twisted, if I have enough shielded and grounded pairs. Due to improvement of the quality of the copper cables, I'm speaking about category 6, category 7, the impact of the noise to the signal is much more lower. It means that's why also level of the noise is much more lower. Due to that, signal noise ratio is very good. It was possible to reduce output level of the signals. Output level of the signal means that the request for output power is now much more lower. Now, as I mentioned already, instead of 10 watts, we are speaking about 4 watts. But the consequence is that it was necessary to improve quality of the copper cables. I am speaking about optical interfaces and cables terminated with RJ45. How it will be done? What is expected that 40G technology will shift frequency range used for data transmission close to 2 gigahertz. Here we are speaking about 1.6 gigahertz, and it will need special frequency tests which are not performed at present. And if you look, the frequency range will increase twice, will be double. It will be necessary to have a special test devices which are able to test up to these frequencies. I mean, I'm speaking about 1.6 gigahertz. Here, I'm speaking about 2 gigahertz, which is very high frequency for copper cables. Okay, what is behind that? Present capacity of the cables category 6A as well as 7A, which are using frequency range maximum up to 1 gigahertz, reach the maximum based on this Shannon formula. The capacity is calculated from the bandwidth multiplied by the logarithm of this sum, where Sn means signal noise ratio. To increase the capacity, it is necessary to increase bandwidth. And how to increase bandwidth? To use upper frequencies. This is I would say, the target. And TIA and ISO and IEEE standardization bodies are working on that and are nowadays specifying limits when the frequency range will be shifted from 1.6 gigahertz up to 2 gigahertz. Okay. The problem, as I already mentioned in the past, was that the devices had to generate very high output power. It means high output power created warming, and the devices had to have a special cooling. If the request for the output power is nowadays less than half, also the request for cooling can be reduced. Means the migration is to have much more, I would say, simple and cheaper transmitters, which are generating, I would say, much more lower output power. Due to that, will not require extra or additional cooling devices, like it is on this slide. In the case of 40G, we are speaking about some limits, but these limits are related to the length due to the fact that any copper cable with increasing frequency is increasing also insertion loss. Insertion loss depends from the frequency. As higher frequency range is used, as higher insertion loss is available on the same pair. Means at higher frequencies there is a higher insertion loss. There is due to that some limit, and this limit is up to 100 meters. This is still acceptable because usually the length of the cables which are required for connection between patch panels, between technology routers, switches, is usually still less than 50 meters. Okay, and where is the problem with the testing? The problem up to now is that there are not yet so many devices which are able properly test this insertion loss and other parameters like noise, signal noise ratio, up these 2 gigahertz frequencies, because there is a serial issue with the stability of the signal. It means you have to generate test signal which has enough stability, which is able to generate signal at very high frequencies. I mean up to 2 gigahertz. And there is not so many instruments available on the market which are able to perform these measurements. Means there is a request to design new test instruments, and JDSU already has available such a tester which is ready to test even category 8 of cables. Conclusion: there is a permanent need for speed and this need for speed will continue. And data center should keep pace, because there is a permanent race between competitors who is able to deliver what. Means all manufacturers of the cables should be able to develop and to test a new generation of copper cables, which allows to go with bit rates up to 100 gig. The consequence is that this media, I mean copper media mainly, fibers partially, are working at the edge of their physical limits. For that purpose, it is necessary very carefully test. In the case of fibers, the main issue is contamination, because there is a very limited budget for insertion loss for these fiber lines between data centers, and each contamination is adding significant portion of insertion loss. That's why it is necessary to keep all optical interfaces clean without additional insertion loss. Also, as it was several times mentioned, MPO connectors are particularly critical, because if one of fiber within the set of optical interfaces is contaminated, you have to remove, you have to disconnect the cable, and you have to perform inspection of all of them, and even cleaning all of them. Means it will take some time. Means one contaminated optical interface can impact the traffic on other fibers due to necessity to clean it, to inspect it. Also, one contaminated MPO connector is impacting plenty of fibers. In the case of copper cables, they will soon exceed 1 gigahertz with gigahertz frequency threshold. For this purposes, you should be equipped with a new generation of test instruments. I guess this is the last page from my WebEx, and you can see from this page that JDSU is already ready to cover these requirements. We have certifier 40G, which is nowadays able to go even beyond the 2 gigahertz frequency range. We are able to certify data cables of category 8, which is going to be standardized this year. For this 40G certifier can be used also for fiber certification. But once again, here we are speaking about insertion loss measurement. To detect the wrong connectors or to detect some breaks or other things, you should perform a standard OTDR. We have such compact one, even with a quad OTDR. Quad means for multi-mode as well as single mode. The same, this is a platform 2000 as well as platform 4000. The difference is just that this larger or longer platform is able to carry 2 modules, 2000 only 1 module. We are equipped, or we are manufacturing optical microscopes, which are fulfilling all these standard requirements for particle analysis. Also, we have a special 2 test tools which can, I would say, substitute certifier 40G in the case of fibers. Means laser source, power meter for insertion loss measurement. Alternative solution for, I would say, lower categories than category 8 is Validator Pro family. We are able to go up to category 7, and also MTS 4000 with special ESAM module, which is for detailed network analysis. I mean layer 2 and layer 3 analysis of data transmission. This is the end of my slides, and now I ask you if you have questions or if something was not clear, you can place questions.
Thank you very much for the presentation, Branislav. If anyone has questions, please submit them via the question and answer panel on the right. Actually, we have 2 questions already. Number 1 is from slide number 10. Will TIA review these figures someday?
Okay, give me a second. So I will give down. Yep, to be honest, we shouldn't expect any special reviews because this is at the edge of, I would say, the fiber limits. What can be changed in the future? In the future, here means I am very skeptic if somebody will change this threshold, but the improvement is expected in a case of optical microscopes, optical connectors. There is a limit, if you remember, 0.75 dB per connector. Maybe in the future there will be a lower limit, 0.5. Also, limit 0.3 dB per splice maybe will be a little bit lower, but nobody, I would say, can tell when and if. But there is I would say, space for change of the limits. Nothing else, because this is related to the fiber in combination with the connectors. If we are able to keep connector much in a good conditions, means we will get the lower values.
Okay, thank you very much. And we have one more question from slide number 11. And it is, are these multiple fibers called ribbon fibers?
Yeah, correct. I guess maybe I mentioned it once, but not too much. Give me a second. Yeah. These NPO fibers are also called ribbon. Means you have, I would say, bunch of fibers integrated in one, I would say, patch cord or small cable. There can be 8, 12, 24, even 45, even more. These flat multi-fibers patch cords or cables are also called ribbon fibers.
Okay. Thank you very much, Branislav, for the great presentation. If anyone has any questions, you can submit them to Branislav or to myself via email. And we'd like to thank you for today's participation, and then we wish you a great rest of the day.
Yeah, I wish you all the best.
Thank you. Goodbye.
Bye.